Hello, welcome to the EPG Pathshala program in linguistics. I am Pramod Pandey, Center for Linguistics, Jawaharlal Nehru University. I am the principal investigator of this project. We are now going to listen to the discussion of a module from the paper Introduction to Linguistics. The coordinator of the course is Professor M30, Professor retired from English and Foreign Languages, University, Hyderabad. The title of the module is
Language in the Bilingual Brain, an Overview of Paper. Objectives: to introduce research using fMRI and ERP for locating L1 and L2 language regions in the bilingual brain. Outline: Introduction, the research question, the factors of age of acquisition and proficiency, the subjects in the studies, the experimental task, results and discussion, summary. Introduction. In over half a century of work following the claim that language is a window into the human mind, disciplines under the umbrella of cognitive science have furthered the aims of linguistic theory in their individual ways, broadly assuming some of the results of linguistic theorization. An area of particular interest to us is the investigation of language in the bilingual brain. In this unit, we summarize the findings from a landmark paper, Perani et al. 1998, that has influenced much subsequent work in this area. The paper is instructive in showing the kind of work that has been done and the care with which the findings have to be interpreted. This research involved collaboration between researchers in two laboratories in Italy, one in Spain and one in France. The paper begins by noting the rising importance of studies in second language acquisition and cortical plasticity, the ability of the brain to adapt and recruit new areas for brain functions that are compromised by injury. To address such questions, one has to understand how multiple languages are represented in the bilingual speaker's brain or mind. The research question. For the first language, there are assumed to be dedicated cortical structures or a neural substrate. This follows from the hypothesis that language is a mental organ. The question is whether or not the second language is also consistently associated with a cerebral substrate comparable to L1. Some researchers have argued that different cerebral networks support L1 and L2 acquisition. The evidence for this is that certain brain injuries may lead to the loss of one language but not another in a multilingual speaker. Nevertheless, neuropsychological and imaging studies have failed to pinpoint a consistent neural substrate for L2, possibly because the various studies used varied task types, subjects whose levels of proficiency in L2 were not comparable, and very disparate languages. The factors of age of acquisition and proficiency. One factor that may affect the cortical representation of language is the age of acquisition. Late acquisition of the first language, L1, leads to impoverishment. Lenneberg, 1967, rooted the idea of a critical period, and children are observed to learn language with better success and greater ease than adults. Late acquisition of L2 particularly seems to affect the phonological and the morphological components. The notion of a critical period for L1 is not unproblematic. However, it is challenged by a study, Varga Khadim et al. 1997, of a patient who acquired language after the age of 9 years when his left hemisphere was surgically removed. After surgery, the right hemisphere appears to have taken over the functions of the left, including language acquisition. An earlier study by Perani et al. 1996 had shown that the brain areas activated by listening to stories in L1 Italian and L2 English were hemispherically different. The subjects were low proficiency, late acquirers of L2. So it was not certain whether the age of acquisition or proficiency was the determining factor. Their 1998 study thus focused on the role of age of acquisition, conducting two additional PET studies to compare with the 1996 study. The subjects in the studies. The participants in the first study were 9 right-handed male speakers of Italian from 19 to 50 years of age who had all learnt English at school after the age of 10. They had all spent at least a year in an English-speaking country and spoke or read both languages in their daily activities. 4 were scientists, 1 was an undergraduate student, 3 were postgraduate students at a school for interpreting, and 1 a teacher of Italian linguistics at that school. In contrast to this high proficiency late acquisition group, the low proficiency late acquisition group in the 1996 study had not been an English speaking environment. They were university students who had learnt English after the age of 10 at school. The language proficiency of the group was assessed with a word translation task using 3 lists: words of high, medium, and low frequency. The medium and low frequency words discriminated the two groups well. Story comprehension was assessed during the PET experiment through 5 questions that followed the scan. The two groups did equally well on the Italian stories but differed significantly in English. The high proficiency late acquisition group did equally well on stories in both the languages. In the second study with early bilinguals, a different pair of language, Spanish Catalan, was chosen because of the difficulty in finding early bilinguals in English Italian. Spanish and Catalan are acknowledged more similar than English and Italian in lexis, morphology, and phonology as well as syntax. 12 right-handed male adults were chosen, half of whom spoke only one of the two languages at home, Spanish and Catalan respectively, during the first 2 years of life. The same assessment tests were conducted on these high proficiency early acquisition subjects. The experimental tasks. In the PET experiments, cerebral blood flow was measured on the high proficiency late acquirer subject while they were listening to a story in Italian, B, a story in English, and C, a story in an unfamiliar language, Japanese. 2 control baseline conditions were used: backward Japanese and attentive silence. Backward speech is physically similar to speech, but it is not speech. There were 4 stories in the 2 languages which were appropriately randomized and switched across the listening groups. For the high proficiency early acquirer group, stories in Catalan, Spanish, and backward speech formed the test and the baseline conditions. Results and discussion. The main result was that listening to stories in L1 and L2 did not yield different patterns of cortical activity in the high proficiency late acquirers and the high proficiency early acquirer group, although it had done so for the low proficiency late acquirer group. That is, age of acquisition had no effect as long as proficiency was held constant. Thus, between the low proficiency late acquirer and the high proficiency late acquirer group, for both of whom L1 was Italian and L2 was English, it had to be degree of proficiency that was responsible for the difference. Auditory language comprehension in proficient bilinguals who have learned L2 after the age of 10 years rely upon a macroscopic network of areas that is similar for both L1 and L2. A second result, given that there was no difference between the Italian English and the Spanish Catalan high proficiency group, was that linguistic distance does not appear to play a major role in determining the degree of overlap of L1 and L2 when proficiency is very similar. The authors acknowledge that their results are different from an fMRI study of L1 and L2 representations, while bilingual subjects were engaged in a silent, expressive linguistic task, using internal speech to describe what they had done the previous morning, afternoon, or evening. The Kim et al. Study had high proficiency late acquirers and high proficiency early acquirer bilinguals and varied pairs of languages. The early acquirers had both languages in overlapping parts of Broca's area, but the late acquirers had L1 and L2 represented in spatially segregated parts of Broca's area. However, in both groups, that is, the early acquirers and the late acquirers, the regions activated by Wernicke's area overlapped. Kim et al. Concluded that the age of acquisition is a major factor in the cortical organization of second language processing. Perani et al. Pointed out that the task of unconstrained covert language production is associated with prominent Broca's area activation, while language comprehension is associated with Wernicke's area, where Kim et al. Failed to find differences. They concluded that brain activation associated with language comprehension does not differ across languages. The understanding of an extended text relies heavily on lexical semantic and conceptual processing. Most of the behavioral limitations observed with bilinguals, however, are related to phonological tasks or to morphosyntactic processing. Secondly, there was no assessment of proficiency in the Kim et al. Task, given a general correlation between the age of acquisition and proficiency. It is possible that the late acquirers were also less proficient than the early acquirers. Thirdly, the use of fMRI allows the study of individual subjects, where the PET studies typically use group averages. Finally, the question remains whether the similarity in brain activation of the high proficiency groups is the cause or the consequence of success in second language learning.